Welcome to the Theta Oilfield Services Rod Pumping Optimization video podcast. This is John Svinos. Let's talk about how to use RODSTAR-D. By the way, if you don't have the latest version of RODSTAR-D, I would highly recommend that you update your installation with that. This is version 3.3 that I'm using here, but by the time you see this recording, there might be a later version, and I would recommend that you download that new version, because we're always fixing bugs, improving the internals of the program, increasing the speed and so forth, adding pumping units and so forth. The first thing I want to say before I start talking about RODSTAR-D is that RODSTAR-D includes RODSTAR-V, and you can easily switch from one to the other by clicking a single button on the toolbar, and that's this button right here. So if I'm now in the deviated mode, but if I want to switch to the vertical mode, then I click on the vertical mode icon, and now I'm in the vertical mode as indicated by the writing here. If I want to switch back to the deviated mode, I click here. Now I'm back in deviated mode. Anyway, when you first launch RODSTAR-D, you're going to see this window here that gives you a quick explanation for the icons on the toolbar. Some of the most commonly used icons, not all of them, but how to start a new case, how to continue to the next window after you enter a window for one of the input windows, and so forth, how to run the program by clicking on this icon, how to open a file, and how to get help with any input items that you might have questions about. So let's get started here by clicking on the first icon on the toolbar to start a new case. When you do that, the program will load not only the first form, but actually all the forms that it will need. So it takes a little bit longer to load the first time, but here it is. The program shows you different colors here. The yellow fields are fields that are mandatory, that you have to put something in before you can continue with the next input window. The white fields are optional, or they already have a number by default. And the cyan field is what is the active field. So when you start typing, it'll show up, whatever you're typing will show up in this field. So for example, I'm going to start typing in the company name here, and it will show up in this cyan field. Then when I click in the well name field, that changes to cyan. So I'm going to type in the well name. Username, comment, pump condition. As you can see, the pump condition defaults to full pump, but you can also select fluid pound or gas interference, or you can have the program calculate the pump condition you will get based on your IPR data and your pumping speed. Pump efficiency defaults to 85%, which is a good number to use to account for some pump wear. Here we need to put in our pump depth, which is 8313. Runtime 24 hours a day. Stuffing box friction is 100 pounds. Polish rod diameter, in this case we have 1.5 inches. The reason why we ask you for the polish rod diameter is because we are doing some additional calculations to account for the piston effect of the caused on the polish rod by the flow line pressure. Here we have tubing and casing pressures. Let's say that the tubing pressure is 76 psi and the casing pressure is 70. You can double click in here, and that highlights the number that is already there by default, and then you can type over it. Water cut is 90%. Water specific gravity is 1.01. Oil gravity is 30, and we will have the program calculate the fluid specific gravity. When you select this option, which is actually there selected by default, the program will use the weighted average of the fluid of the water specific gravity and oil specific gravity to calculate the fluid specific gravity. Or you can uncheck this checkbox and put your own number in there for the fluid specific gravity. In some cases you might want to use a lower value if you're dealing with an existing well to account for free gas, for example. But in this case I'm going to leave it as calculate. Okay, so now we can continue with our next input window by clicking on the next window. And here we have to put in our production information, production information and pumping speed. So or actually fluid level pump and production. The first thing that the program wants you to put in is either the fluid level or a pump intake pressure, or you can have the option to calculate the pump intake pressure from target production and IPR data. As you can see, the program defaults to entering a fluid level and puts the fluid level at the pump. Now you can also select to enter a pump intake pressure. You can put whatever pump intake pressure you want here, but in this case let's leave that as let's put something here to get out, because you shouldn't be putting 0 for the pump intake pressure. And then let's put in the fluid level at the pump, because that's worst case conditions. That will give us the highest loads on the plunger. Here I can select either to enter a pumping speed, in which case the program will calculate the corresponding production, or I can enter the target production, and in essence when I do that I'm asking the program to calculate the pumping speed that I need. Or if I have IPR information, I can select to enter that instead. We will come back to this later. For now, let's say that we have a pumping speed because this is an existing well. So I'm going to select that option to put in. So I'm going to put in 8.46, my pumping speed for this system. And now I'm going to go to the next input window by clicking here. And that gives me the pump and tubing information window. The tubing size is 2 7/8, which is the default, so I'm going to leave it like that. My pump is an insert pump, but my plunger size is actually 1 1/4 inches. My tubing anchor depth, let's say it's at 8250. And here we have the upstroke and downstroke raw fluid damping coefficients, which by default are 0.1 and 0.1. You can change these numbers if you have a measured dyno and you bring it in and you are trying to match it with a predictive dyno. But if you don't know what to put in, you can leave it as the default of 0.1 and 0.1. For the pump friction, again, we recommend that you leave it at 200 pounds unless you know a reason to change it. For example, for a tight pump, you might want to use a bigger number for the pump friction, or for a looser pump, a smaller number. The option to include buoyancy effects should not be checked for either steel or fiberglass rods. Actually, let me explain what this does. The buoyancy effects are always included in the calculations, but this option allows you to see the final results with or without buoyancy effects. The reason why we don't want to include buoyancy effects is because buoyancy effects do not cause buckling. So if you include them, you will see a lot of negative loads on the bottom of your rods, and that makes you think that you need more single bars, so that your rods may be going into buckling, when that may not be true. So that's why we recommend not including them and looking at the results without buoyancy, because that's a more realistic view of whether your rods are in buckling. In addition, of course, in a deviated program you have the buckling tendency plot, which tells you how likely you are to buckle. The include fluid inertia effect option is grayed out because this is not a group 2 well. Group 2 wells are shallower, high rate wells, typically less than they're 3,500 feet or less, with 2 1/4 inch plungers or larger. Obviously in this case we're not in that range, we are deeper and we have a smaller plunger, so this option is deactivated. So let's go to the next window here, and this allows us to put in our rod string information. Now there are three ways you can put in the rod string. One is by asking the RODSTAR to design the rod string for you for steel rods only, or you can have RODSTAR design a fiberglass and steel rod string for you, or if you're dealing with an existing well, you can select this option, which is the manual rod string entry. Now when you select that option, the next thing you need to do is select how many sections you have in your rod string. So I'm going to click on this item here. That's the number of sections in my rod string, and in this case I have 4 sections. I'm going to select number 4. This will automatically create a grid for me to put in my rod grade, size and length, and also the friction for each rod. So all these rods that are in this well are Weatherford Electra rods. So I'm going to drop this down. I'm going to go to the bottom of the steel rod grades, and I'm going to find Weatherford Electra. And by the way, if all the rods are the same, you don't have to do the same thing for every rod. All you have to do once you select the top rod is to click in the middle of the next field or somewhere in the field, and it will automatically make it the same as the one above. See, that's a fast way of putting the same rods in there. For the rod diameter, the same thing. The program actually defaults to 1 inch as the top rod. If that's what you have, which is what we have here, that's fine. If you click in the next field, it will automatically put it to 7/8. If you click on the field below, it will automatically put it at 3/4. But the last section here is not 5/8 as the program would automatically put in, but 1 inch, because that is a sinker rod. It's a section of rods used instead of sinker bars. So now let's work on the lengths. The length of the first section is 1950 feet. The length of the second section is 2200 feet. The length of the third section is 3560. And the last one is 600. Now you might notice that the program defaults to the difference between the pump depth and what I put in already. So it's not quite 600, but it's pretty close to it. We actually allow you to be up to 50 feet off, because in most cases you don't put in your polish rod length or your pump length. So your rod string is going to be probably a little bit shorter than the pump depth, which is okay. You can be up to 50 feet off. The program will not complain. But you cannot be longer than the pump depth. So to make sure, we show you here the rod string length versus the pump length, and if these numbers are in red, that means that there is a mismatch that you need to correct. Now for the friction coefficients, the 0.2 is a default, which is okay for the average well. That's the friction between steel on steel, steel rods and steel tubing. But if you're using rod guides, you need to increase that number slightly to account for the additional friction of the rod guides. You can find out from the rod guide manufacturers how much the friction is going to go up by, and then adjust these numbers accordingly. For example, if the rod guide manufacturer tells you that these rod guides will cause 20% more friction than normal, than steel on steel friction, then you multiply 0.2 times 1.2 and you use the resulting number. I don't know what that is, but let me pull up a calculator here and we can figure it out. So if the normal friction is 0.2, and then you have a section with rod guides that have 20% higher friction, if I multiply 0.2 times 1.2, in other words 20% more, then I get 0.24. So then what I would do is, in the section that has those guides, I would put in 0.24 for my friction coefficient. Now at first you may not know what to use because you haven't made a run yet. So at first you use the default values, you make a run, find out where the program recommends that you put your rod guides, then you can go back and adjust your friction coefficients accordingly. Alright, so now in this portion of the input window you can put additional costs. This allows you to compare runs based on cost as well as loads. And we have an option in the setup of the program where you can put in cost in dollars per foot or dollars per meter, and the program will calculate the rostering cost for you. This allows you to put in some additional costs not covered by the dollars per foot or meter. Like you might put some pony rods or the cost of rod guides, for example. That way you have a more accurate total for your rostering cost. And here you can put a description of what this cost is for. Alright, in this case I'm going to leave this blank. Here you put in your service factor. That's a number that allows you to derate your rods for non-ideal downhole conditions. And actually, this might be a good place to show you the help that we have in the program. If I press F1 here, the program will give me help on the service factor. Okay, I'm going to close that. I'm going to go to the next window. And by the way, notice that as I'm advancing from one window to the next, the previous window icons, I'm sorry, let me rephrase that. The icons for the previous input windows that I've entered data for activate, and I can go back to them. So if I go to the next window here, you can see that the icon for the other input windows activates. Anyway, this window allows me to put in my deviation survey. I can manually type in my deviation survey by putting in my measured depth, inclination, and azimuth, or it might be a lot easier to bring it in, to import it from an Excel. I'm going to browse to the directory that contains the Excel file, which is right here, and then I'm going to click on the Excel file and click open. This places the path to that file in this input window here. We're going to click next, and now the program says please wait. It's going to go and look at that file that I specified and try to find the data, the 3 columns we're looking for in that file. And there it is. It found the 3 columns. It found measured depth in column number 1, inclination in column number 2, and azimuth in column number 3. And also it knows that this is English units. So if everything looks fine, you click next. And now the program says please wait. Now loading data from file. So it's actually accessing the data right now from the file that we specified. Okay, it says here read completed successfully, so the data is being brought in. Now once the data is brought in and you can look at it, you can see that the first 3 columns, the ones that were brought in, are white. The rest of the columns are grayed out. Those are not accessible to you. These columns are calculated by the program based on the 3 columns you put in. Another very interesting option here is the plot survey option on this tab. If you click on that, the program will give you a 3-dimensional plot of the wellbore, color coded according to the rostering sections we put in. So the red color here is for the top section in the rod string, the green color is for the second section in the rostering, the blue one is for the third one, and so forth. Also here from this window you can click on the rotate button here, this button right here, and this allows you to rotate the plot by clicking and dragging on the mouse and looking at it from different angles so you can better visualize what your wellbore looks like. You can also zoom in the same way. You click on the zoom button here and then you can click and drag and zoom in to your to any part of the deviation you would like. If you want to move a specific portion of it, you can click on the move icon, and then again you can click and drag the mouse and move anywhere you want. If you want to go back to the original plot, all you have to do is click here, and that takes you back to the original plot. And if you wanted to copy this plot so you can use it in another document, all you have to do is click here, and that actually copies the 3-dimensional plot, and then you can use it in another application. Okay, so let's continue with the next window here. which is the pumping unit information window. Now, the pumping units that we show you here are listed by manufacturer and by stroke length and gearbox size. So the first thing you need to do is select the manufacturer of the pumping unit. In this case, is Lufkin Conventional and U, and then you go first by the stroke length. For example, the unit that I have here is a 456, 305, 144. So I'm going to page down until I see 144-inch strokes, and then I'm going to look for my specific unit size, which is a 456, 305, 144, and there it is. And as soon as you click on it, the program shows you the pump unit ID, which is a unique ID for each pumping unit we have in our database, and also any other information about the unit, the name, the designation, and so forth. And then you can select the direction of rotation of the unit. In this case, is going clockwise. The stroke length, which in this case is crank hole number 3, 107-inch stroke. The program automatically shows you the structural imbalance. And here, if you don't know what kind of balance moment you need, you can leave this as unknown, which is the default, and the program will calculate the counterbalance moment you need to balance the unit. If you have our XBAL program, you can then take what the program calculates as the required moment to balance the unit, and you can export that back to XBAL to find out what weights you need and where to put them to get that. Also, you can use XBAL for an existing well, and then in that case you would select this option here to be able to bring that data into the program. But in this case, let's say we don't know what moment we need, so we're going to say it's unknown, which means the program will recommend what we need. So let's go to the next input window. This is the electricity cost input window, where you put in how much you pay per kilowatt hour. Let's say in this case it's 10 cents per kilowatt hour. Select the power meter type. D10 means you get no credit for generated power, because the power company puts a ratchet on the meter that only allows it to rotate in one direction. Non-D10 means that the meter can rotate in either direction. So when the pumping unit generates power in a certain portion of its stroke, you get credit for that. In most cases you don't, so it's better to select D10. And then the program automatically defaults to NIM and D motor size, which is the most common and RODSTAR recommendation. And if you want to include speed variation, you can do that. Otherwise, you leave that blank. Actually, in the deviated program, we don't have that capability yet, so leave that off. All right, so now we've entered all the data. The program is asking us, do you want to save this data to disk? If you say yes, the program will automatically make up a name for you based on the well name you put in. I'm going to change that name at the end by putting a number 3 next to it, so that I know this is the latest file. And I'm going to click on save. Now that I saved my data, now I can run it by clicking on this button here. So now the program shows on the status bar here that calculations are in progress, please wait. And this is a deviated program, so sometimes it can take a little while to finish the calculations, although this version here is the fastest we've ever had. So in a few seconds we should be able to see the results. So now it's telling us that it's loading the output results. So the calculations have been completed, and the program is simply loading the results for us. So here is the output report. We can see the peak and minimum loads here, the ratio of the minimum polish rod load to the peak polish rod load, the structural loading, which is 93%, that's good, and all the other output numbers that we need to look at to decide if this is a good design, including the rostering, stress loading, the gearbox loading, balancing information here. For example, in this case we need to have a 1,554,000 inch-pounds of counterbalance to balance the unit. And here is the stress loading on the rods. And if we go to the next window, to the next page, I mean, we're going to see the deviated plots, side load as a function of depth, max and min axial loading as a function of depth, buckling tendency, dogleg severity, and also how the wellbore looks, looking west, looking down, or looking north. I can also see the deviation plots by themselves by clicking here, and that will give me each plot by itself. By the way, the different colors here corresponds to the different sections in the rod string. So the red color here is the 1-inch section, the green color is the 7/8 and so forth. So I can go through each of these plots one after another by clicking on next here. Also, I can look at the dynamometer plot by itself by clicking here on dynamometer. That will give me my surface and downhole dynamometer cards. The surface card is the blue line, the downhole dynamometer card is the green line, and the red line is the permissible load diagram. Okay, so you can see that the dynamometer card fits into the permissible load diagram. It does not intersect it, and this is what we want to avoid overloading the gearbox. At this point, I can also animate the dynamometer cards by clicking on the play button for the animation, and I can see how the surface and downhole cards relate to each other. I can see the stretch in the rods and so forth, the delay in what happens at the surface versus what happens at the pump, the relative speed of the polish rod versus the relative speed of the plunger. So it's a useful option to have. I'm going to stop this animation here. And another thing you can do is you can look at the torque plots. And this gives you, in this case, there is only one line because this shows the line for a balanced unit. So this is the net torque on the gearbox on the upstroke versus downstroke. As you can see, the two peaks are the same. That's what you need to have to balance the unit. And if you're going to go back to the report, you click on the report icon here, and you're back here. Now this is page number 2, as you can see here. If I want to go to page number 3, I click here, and this is the first page of the rod guide recommendations. So the program here shows me where I need to put my rod guides based on the side load that it calculates. So in this case, I need 2 rod guides minimum here, and here I need 4, here I need 3, and so forth. But notice that this 2 has a double asterisk before it. If I go down on the bottom of this page, I see that the manufacturer of these guides recommends a minimum of 3. So even though the program calculates 2, I actually have to use 3 because that's what the manufacturer recommends. And there is 2 more pages of these recommendations. Okay, so that's how that works. Now you can also print this report by clicking on the print icon either here or here. You can also zoom in or zoom out of the report by clicking on these buttons here. This probably is more useful in a page like in the first page of the report. Let's say this page here, if I click on the plus symbol, that increases the size of the letters so I can more clearly see what the report says here. Good for older people like me where we need glasses to see the output. Or if you have a big display, you can click on the multiple page view, and that allows you to customize your display. If I want to see, for example, 2 pages one next to the other, I click and drag on the 2 pages view, and that will give me 2 pages at a time, one next to the other. If I have an even bigger monitor and I want to see 4 pages at the same time, I can do that. Or I can go back to 1 page by clicking here. You can also search for any item you want on the output by clicking on the find icon, which is a pair of binoculars. So for example, if I'm looking for gearbox loading, I just put in gearbox, press find next, and the program will find the first item that starts with the name gearbox, which is right here. So that's how simple that is to do. Okay, so when you look at your report and you find that there is something in the report that you don't like, that you want to change, there are a number of options that you can select to do that. If you are new to RODSTAR-D and you don't remember what window contains what variable, you can select the visual input option. See right here? You click on that. That brings a visual representation of the wellbore, and then you can simply point to the item you want to change. For example, if I want to change the rod grade, I select rod string, right click, select rod string here, and the program takes me into the rod string input window. And then I can change anything I want by the rod string window. If you wanted to change, let's say, the pumping speed, if you don't remember where it is, let's say you go to the pumping unit, you right click on it, that is the pumping speed or target production. You can also get the same thing if you go to the motor information. We have it in more than one place. See, there's the pumping speed right there. So that's one way you can do it. Another way you can find the variable you want to change is by clicking on the alphabetical list here. That gives you an alphabetical listing of all the variables you can change. Another way to do it is to directly go to the input window you want, which is by clicking on the icon here on the toolbar. Some of these are easier than others. For example, this is the motor information window, so obviously you can go there to change things that have to do with the motor size or energy consumption. This is the pumping unit information window. This is the deviation input window. This is the rostering information window. This is the pump and tubing information window. This is the production information window, and this is the well information window. So for example, if I wanted to go to the deviation input window, I would click here, and that takes me to this window right here. Okay, if I wanted to go back to the rostering window, I click here, and that takes me to this window. So that's how that works. Okay. And by the way, you don't have to close these windows, these input windows, to rerun the program. If you are done changing a variable, for example, I can change the pumping speed or the pump size and so forth, and then directly from the window where you make the change, you simply have to click run to rerun the calculations. The program will automatically close those input windows by itself and then show you the results. So again, this is calculating now. There are a number of other options that I'm going to discuss, but this is the way that you would start and enter data for RODSTAR-D. This is kind of the first, most simple video that I can come up with to explain how to use the program. In subsequent videos, I will show you some more advanced features of the program. Thank you for your attention.